Today we're going to talk about section 7.6, adding and subtracting polynomials. It's a fairly simple section here. It's something you probably already know how to do. We've talked a lot about it earlier in this year with like terms and things like that. So I don't think you'll have too much problem with it. It's really a three-step process to add or subtract polynomials. Really, the first thing you got to do, the biggest, most important thing, is identify like terms. So, for example, you look at something down here like this, and we have a polynomial with multiple terms here. And the idea, remember, is to identify where we have like terms, right? So we have 5x to the third, we have 2x to the third. These two things are going to be like terms. So first thing you want to do is identify those, look for some like terms. And then what we can do is we can rearrange it. Basically what we're doing is we're using the commutative property, where we can just take, like these two terms here and rearrange those so it's 2x to the third, and then we put the 5x to the third, and then the 4x. So basically we just flip-flop those, right? Commutative property says we can do that. So we rearrange that, and the purpose is to get those like terms next to each other, and then we can just combine those two like terms. So we have 2x to the third, we have 5x to the third, which makes 7x to the third, and then we have that 4, okay? So we'd be done there. A lot of people, once you get the hang of this, we can kind of skip that second step where we rearrange those, and once we identify, we can go straight to that. Try another one. Here we got 9b to the third c squared. We got 5b to the third c squared. So these two things are like terms because they have the exact same number of b's and c's. This is also b to the third c squared. So all three of these things are actually like terms. And it's important to note they have to have the exact number of b's and c's. If I throw another plus 7b to the third and I just put a single c there, this would not be a like term with those because it has to have the same number of b's and the same number of c's in order to be a like term, okay? So in this case, all we would have to do is actually just add these three together. We got 9 of these, we got plus 5 of those, which makes 14 of those. And then 14 minus 13 would be 1 of those. And because it's a 1, we actually don't have to write the 1. You can write the 1, it's not wrong, but we know if we just leave it blank like this, we know that that's 1 of those. And then all we have to do is just throw in whatever other terms we have. And then again, it's important to make sure it's in standard form. That's why I put the x to the third first and then the single constant next. This has a higher degree than that. So, again, that would be in standard form. Okay? So let's try a couple more examples here. Sometimes we have parentheses. Well, in this case with a plus, you can kind of think you're going to distribute that plus through there, but basically we can just rewrite this where we actually don't need, we can just say plus x to the second. We don't need the parentheses. Plus, and then we have the 3x, and we have the minus 1. Again, identify like terms. We have like terms here, and we have like terms there, so we can just kind of flip-flop those. 2x squared plus x squared, and then we'd have that minus x, we have that plus 3x and minus 1. So basically just flip-flopping those two terms there to put the like terms next to each other, and now we can just combine. 2x squared, 1x squared makes 3x squared. So combining those, and then we can combine these. Negative 1x plus 3x makes 2x, and then we have our constant down there. And that's it. Similarly, we can rewrite this, or we don't actually have to write this. This is plus. We have a like term. We have a like term there. We would combine those two things. But negative 2ab's and positive 2ab's, those would just cancel each other out. All we have left are those a and the b's. So yes, b plus a would be correct, but standard form does kind of tell us we should also put things in alphabetical order, especially when the degrees are the same like that. A plus b just looks better than b plus a. So let's try another one with a minus here. when you see a minus, it really is important to take care of that minus first. And the way you want to do that is basically just distribute that negative through there, through that second term. So this becomes a negative of a positive, makes a negative 3a to the fourth. We have a negative of a negative that makes that 3a positive 3a. And then that would turn into a negative 1. So we're going to want to change all the signs of that second term. Now we can identify and combine like terms. We have 1a to the fourth, and we have a negative 3a to the fourth, which makes negative 2a to the fourth. We have a negative 2a, we have a positive 3a, which makes a positive a. And then we just have that constant there at the end. All right. Let's try one more here. Again, we have a negative with parentheses like that. It is important that we distribute that negative through that second term. So we're going to have a negative y to the third, and then we're going to have a positive 5. So we change those signs. Now we just identify and combine like terms. So we have 11y to the thirds. We have a negative y to the third, which makes a positive 10y to the third, is 11 minus 1. We have that 2z there, and we have our constant of 5. So that's really about it, guys. Try a few examples. I don't think you'll have too much problem. We've talked a lot about like terms in the past, and I think you guys just did just fine earlier this year with that. So let me know how it goes. Other than that, I'll talk to you guys later.